Hello friends, welcome to part 2, decoding section. Uh, Today we are going to develop smart contracts, and inside the VS Code I am defining some dependencies that we are using on this project. We are using a Foundry, is a main smart contract development. It gives you a lot of tool chain from build to test to deploy, verify, integrate, and many other useful things. Also, we are using a package called OpenZeppelin. I think anyone know OpenZeppelin, what is it? And it's for security stuff. And make sure you define a .env file. This .env file contains your private key, your contract address, and your zk-SNARK RPC URL. I am using Alchemy. You can use any node provider you're familiar with it. You can use, I think, Amphoro, QuickNode, and yeah, this is the most known in the Web3 infrastructure. Probably you will use your wallet address. Make sure your wallet address is on zk-SNARKs Sepolia testnet network. And if you don't have some balance, this is just a test wallet for sure. If you don't have some balance, you will go to zk-SNARKs Sepolia. This is for requesting some balance, and the balance is important for to pay gas during development the transaction. And yeah, okay, so let's go. Okay, friends, we are now defining the dependencies. So let's work on the projects by typing the first comment is for init for starting the project. And you may face in this problem. You can just do force. Cool. Let's rename this to election or election voting, or we can type just voting. Cool. We are using a version. This is, I think it is old version. We are using 0.19. It's compatible with zk-SNARKs L2 for low gas fees and the latest safe version in Solidity. Let's delete this stuff. And the first contract. I think we install some dependencies by go by importing some OpenZeppelin features. Okay, let's install via npm or 4. Please. First install OpenZeppelin. No commit. Okay, let's complete this smart contract. Let's do contracts election voting is our enable and return efficiency gap. I think this is something. Election voting is enable, and the ownable keyword is let only the owner, I mean the election authority, call sensitive function. And I think we are not using isDCA, this cryptography method, because I use this when I work on a project using Circom, but I think it's not important. So let's comment it, and we'll check in the last in the code if we are will using it or not. And the recurrency guard is to protect from recurrency attack, especially on cast vote. And okay, the OpenZeppelin is installed successfully. And now let's define some structs. And the first struct we have is called candidate. This is represent a person standing for the election. It stores name, party, and how many votes they will receive. We have unit 200 is ID and string name And another string is for party, and line 265 is vote count. Another struct is called voter, and the voter is each voter registration, and it's sorry, the stream was off. Let's back continue. So I say the voter is for each voter registration and the voting status. The first parameter is registered, and the second is who has voted. Voted candidate ID. Okay. Okay, the last parameter is bytes. 32 for vote count. Okay, fine. And we are defined two abstracts. Is the candidate and the voter. Now we are working we are using some set variable, and the first for election meta. We are using a variable is a string public. The string public is election name, and UInt 256 is public start time, and another var is end time, and this election for store election name, and the track if the sessions started or ended, and we add some two parameter again is bool public, and the bool public, the bool for election started, and the second one for election ended. Okay, election ended, election started. Semicolon, and some storage for candidate of voter. We're using mapping. Well, for anyone no one familiar with Solidity, Cypher draft each teach anything about Solidity, and you can also go to Solidity by example. You can learn any keyword or any function you don't understand, or any method you don't understand. You can find it on Solidity by example. It covers a lot of parts. Okay, the first mapping is UInt 200 is for candidate return public of candidates semicolon, and mapping address is voter is return public for voters, and the mapping of bytes. Come on, it's return public. Newly pure hashes. Okay, this keyword or this variable, it stands for help us to prevent double voting using zk-SNARK identity nullifiers. And now some meta info. Well, the candidates is ID-based map for all candidates, and the voter is maps user address into their voter record, and some meta info. Okay, address public zk verifier contract. This info for track total for candidates, voter and vote count, zk verifier contracts, and UI 206 is a public for candidates count, and another is UI 200 registered voter counts. Is total votes cast. Okay, cool. And now some events. I love doing this method on a smart contract development. First, I've been defined the structure, and if you have some meta info, some storage for like this for this candidate or voter, and now I will go in if you have some events for is crucial for front-end indexing or log tracking and if you have some constructors and modifier and then at last I will go to implement the core function, and this is give me the ability to easy of development, and if I face some problem I understand what the problem is, and I think this method is very good for me. And well, now is for events. The first event is for voter registered is address indexed voter, and the second event is for vote cast. Cool, is for bytes is bytes 32 indexed. Okay, only semicolon. Third event is return candidate. Other is behind 200 is end in time, and for total voucher. Yeah, I think we're done, or still we have some we are doing candidate added for election for event for election election ended, and an event and for event is for election starts. No, I should do ended at least, and election start. The election starts with return rewind 200 is a start time, and rewind end time, and the event election ended is return and in time, and you are doing the total votes is not vote cast, it's votes, and you are winning candidate Let me check if we have still missing some. When check when candidate, this when candidate ID, when candidate ID and string of winner name. We are missing some total voucher and time and string name. Start time and time. And event candidate added is that's the problem. Okay, I think the candidate added. The candidate added is returned index of candidates ID and string name string party. Okay. So check if we still have some constructor. I think we are moving now to the constructor. Okay, the constructor. Well, this constructor is for initialize election name. Set the deployer as the owner, and the permission we are using is constructor return string memory of election name. Sorry. Election name and return. Why will not answer? Message dot sender. Election name equal election name. Semicolon. Let's start on zip via npm. Come on. Open zip with last one. I will check it later. Let's continue the code. And then we have the modifier. The modifier let's do only before election, add candidate and start election. And just two. Okay, I solve these libraries manually by taking the OpenZeppelin folder from the lib and Actually, I solve it manually by taking the open zipping from the lib folder, and now we define some modifier. Uh, this modifier is modified only during election and the only before election. The only during election, it's in your cast vote function only happen within election period, and the only before election, this limits candidate registration and the voter registration before election starts. And now we will do some core functions from add candidate, start election, end election, voter registration, etc. Hello friends, welcome again, and this is a to-do function that we are using in this project, and the function add candidate is responsible for adds new candidate before election starts, and start election is when you define the duration and the set time stamp. Also, end election is identify the winner and emit the final event, and register voter, useful for register voter and the batch register voter. This function is useful for testing multi-voter in Foundry. Also, cast bot is for verify the voter. Check the nullifier is no double voting, and also verify zk proof, increment candidate vote count, store nullifier, and update voter status, and verify zk proof for verifying zero knowledge proof, get election results, and get candidate. This is get election results, get candidate, get winning candidate, is return array of all candidates with their counts. And yep, okay. And at last, get election status. This is for front-end summary, like give you all candidates, votes, stars, and times. So I'm not missing anything. Okay, let's do a test. Let's create a test file. Let's remove this. We have the voting and the test. Let's edit the version. Okay, let's make a contract called election voting test is test. Was SCE test also good. Let's do function setup. It's a public. Setup. Let's define election voting is a public. Is a public voting.
Ah. We define tree address, publish again. Equal address 1. And the function setup is for deploy contracts from admin. So we'll start vm dot start start prank is admin. ElectionVoting let's add some candidates. The candidates and register the voter. Okay, and now doing VM stop blank. I'm adding some functions, some test functions, like add a test election lifecycle. This will start the election and confirm the name and status, and start the election using VM start rank. Check election status, cast a vote, VM start rank, and election using VM.wrap is for end the election after 61 minutes using VM wrap, and check results. And at least is a function test double prevention. This for test validate use zk-SNARK style anonymity with double vote protection. So here they start election and cast vote, then start blank and try to vote again with the same nullifier. So what we still have is a script, and let's say deploy.c dot sol. And let's take the same version. Let's say contract deploy election voting. Let's import so function run. This is the entry point of the scripts, and let's say you want deploy private key equal VM vote in the orange private key. This is for load your deploy private key from d.env file. Start broadcast. Let's do election voting. Is voting equal new election? Nice. Let's do national. And in the broadcasting session, so let's do VM dot bro broadcast. Stop broadcast. And let's do console.log. The the console log the deployed contract address to the terminal and only show in rerun or during broadcast. So let's type election deployed at address of voting. I think I have some problems in my VS Code. The library is installed successfully, right? So we'll fix this problem. So right now everything working fine. I'm fixing all the errors. So let's do for build. Compile successfully. And the next command is now let's do test. Okay, the tests also fine, and let's do test run with logs. And run the specific text from like March test. Let's do election. Okay, cool. And let's run for scripts. It's for deployment. For script, let's take failed vim.env. Make sure you set up your .env file. So I will stop the recording to make the private key, zk-SNARK app URL, and the compression address. Okay, I'm set up in my .env. So let's do. Okay, here is the deployed address. And do .txt. And let's do for scripts for wait. Fine, script ran successfully. The transaction saved to deploy. Where? To the broadcast. Okay, cool. I think we complete everything. So okay, as we see, here's the deployment process: gas fees, chain, and exchange amounts. And I'm creating a file called verifiable. This script is automate automated contract verification on zk-SNARKs. It's no manual setup, no guessing pass, so it covers everything. Install all dependencies, configure hard hats, and so to run the contracts on the zk-SNARK Explorer. And so this is my script that I use in all my projects. And let's run so cd verifier. Verify. Yes. Okay, I run it manually, so the verification script is running successfully. So the verification process is complete right now. And now let's doing some integration using cast. And this is interacts with the deploy contract directly from CDI using Foundry. And first, let's release a voucher using cast send contract address, your okay, cool. It runs successfully. And now let's do start election. Start election privacy. Yeah, see URL. Logs, gas fees, dog hash, and phone, gas usage, statues, and there are several methods you can use. So let's do just get election statues. Gas card, contract address, get election statues. Well, now let's check zk-SNARK Explorer. Okay, now we are in zk-SNARK Explorer, in Sepolia Explorer. So let's try the contract address, and let's see the method that we are using. Edit the method we are using before, the start selection, and let's see this on the chain, and this fees, low gas used, and this is the power of L2, and this is the other method utilization of water. Okay, now the project's completely fine. So what we have at least. So thanks everyone for watching. I think this video is very long, and but they share many advanced techniques, many advanced concepts. So I hope everyone like it, and see you in other tutorials. Thank you so much.